this video lecture, I will be telling you all about the equations of circles. First, I will tell you how we can derive the equation of a circle. Second, I will tell you how to find the equation of a circle with a given central point and a given radius. Finally, I will show you how to find the center and radius of a circle, as well as how to graph it from an equation. In order to derive the equation of a circle, we're going to need a precise definition. Sure, a circle might be something that's perfectly round or some such, but ever since antiquity, the precise definition of a circle has been the set of points which are the same distance from a fixed central point. So if we want to get the equation of a circle, we want to start with distances. With that in mind, we're going to remember the distance formula, which gives distance between 2 points in the plane. So the distance formula says that the distance between, say, a point x1, y1, and the second point x2, y2 is given by the square root of the quantity of x1 minus x2 squared plus the quantity of y1 minus y2 squared. Now we are going to use the distance formula to derive the equation of the circle. So suppose we have a circle, the circle picture here. Its center is at this point AB, and its radius is r. So therefore, all the points on the circle are the points which are a distance of r from AB. Now suppose xy is on the circle. That means the distance between xy and AB is r. So now by using the distance formula, we get that r, the distance, has to be the square root of the difference in x values, so of x minus a squared, plus the difference in y values, which is y minus b. And then that needs to be squared as well. If we go ahead and square both sides, this implies that r squared is equal to x minus a quantity squared plus y minus b quantity squared. In summary, if you have a circle centered at the point AB with radius r, then its equation is given by the quantity of x minus a squared plus the quantity of y minus b squared equals r squared. So for example, if I want the circle centered at, say, the point minus 1, 2 with radius 5, and I want to get its equation, I simply use this formula where a is going to be minus 1, b is going to be 2, and r is going to be 5. Therefore, the equation of this circle is x minus 1 quantity squared plus y minus 2 quantity squared equals 5 quantity squared. And of course, this could be tidied up slightly. I don't recommend you actually multiply out the stuff you have in parentheses. However, it is nice to say that x minus 1 is the same as x plus 1. And we'll go ahead and say that 5 squared is 25 as well. So therefore, the equation of a circle centered at minus 1, 2 with radius 5 has equation x plus 1 quantity squared plus y minus 2 quantity squared equals 25. Now, what is arguably the most important circle in all of mathematics is the unit circle. This is the circle which is centered at the origin, which is the point 0, 0 on the plane, and has radius 1. So using the equation for the circle, we just need to plug in 0, 0, and 1. So this is going to have equation x minus 0 quantity squared plus y minus 0 quantity squared equals 1 squared. And this simplifies to the nice, elegant equation x squared plus y squared equals 1. And if we go ahead and graph the unit circle, it's centered at the origin, its radius is 1. So we're just drawing the circle of radius 1 centered at the origin. And I realize my drawings aren't the best, so you have to use your imagination a little bit, but hopefully you can imagine that as the circle is centered at the origin with radius 1. This circle is very important in trigonometry. In fact, the definition of all your famous trigonometric functions, which we'll be learning about later, such as sine and cosine and tangent, they're actually all done in terms of the unit circle. So we'll be seeing a lot of this guy later on in the course. For the final part of this video, I'll explain to you how to find the center and radius of a circle given to you by an equation. Now, a lot of times you're not going to be given an equation exactly in the form x minus a quantity squared plus y minus b quantity squared equals r squared, where you can just read off that the center is ab and the radius is r. Instead, you might be given something like this. We've got x squared plus 8x plus y squared minus 6y equals 2. So what we want to do is manipulate this equation so it looks like a perfect square in the x plus a perfect square in the y equaling a radius squared. In order to do that, we have to remember the technique of completing the square. Now, a perfect square in x is going to look like x plus c quantity squared. When we multiply this out, we get that this equals x squared plus 2cx plus c squared. So this part of the perfect square looks exactly like this x squared plus 8x that we have here. In fact, in order for this to be this part of the perfect square, you can figure out that you just do the 8 over 2, and that's going to be c. So in other words, c would have to be 4. And then we can do the same thing with the y terms. So we start with x squared plus 8x. In order to make it a perfect square, we go ahead and add in 4 squared. The great thing about mathematics is you can do whatever you like, so long as it doesn't change, so long as you get an equivalent equation. So if we added 4 squared to one side of the equation, we'd better add it to the other to keep from changing things. And now we're going to do the same thing with the y terms. In this case, we take the minus 6 and divide it by 2 and get minus 3. So therefore, to make it a perfect square, we need to add in minus 3 squared. And once again, in order to keep from changing the equation, we need to do it to the other side of the equation as well, so that we get an equivalent equation. So I'll go ahead and add in minus 3 squared on that side of the equation. Now we can simply simplify, and then once we write these as perfect squares, we can simply read off what the radius and center are. So this is the perfect square, x plus 4 quantity squared. This is the perfect square, y minus 3 quantity squared. And now doing a little bit of arithmetic, we've got 2 plus 16 plus 9. I get that to be 27. So now we have things perfectly in the form x minus a squared plus y minus b squared equals the radius squared. So from this, we can simply read off that the center is at minus 4, 3, and the radius has to be the square root of 27, because of course we want the radius squared to